Okay, today we're on to 2.7, the X factor. Now that Optimus Quilts is accepting orders for rectangular blocks, their business is growing in leaps and bounds. Many customers want a rectangular block that's bigger than the standard square block on one side. Sometimes they want one side of the block to be the standard length X, with the other side of the block 2 inches bigger. Draw and label the block and write two different expressions for the area of the block. Okay, so standard side X and the other one with 2 inches bigger. So here is your standard size, and then 2 units bigger. Still got to be a square, but you have to add these 2 units. So it would look something like this. Write two expressions for the area of the block. So this would be X plus 2, and that's coming from the top, times X. Another expression would just be to name the tiles, which is X squared, X, and X. So that would be, which is the same thing as we would have gotten if we had used the distributive property here. Let's take a look at number 2. This time we have the standard length X and one side that is 2 inches less than the standard size. So on this one, it's a little weird. You have this, and then you would normally have this, but it's 2 inches less. So you have to come in here, 2. So essentially, this is one side, and just this part is the next. So that would be X times X take away 2. And then we could distribute just like before, where we would have X squared minus 2X, which is what we have because this is X squared. And then these two are kind of viewed as negatives as it's coming on in on the side. Let's see. Let's do another one. Okay, sorry I'm not reading all the instructions, but I'm sure you're fine. Number 3, one side is 1 inch less than the standard size, and the other side is 2 inches more than the standard size. Okay, so that's how number 3 is going to look. We're going to have X squared. Just a little hint here for drawing them. I just draw an X squared, and then the side that is more, I add on to the right. And then the side that is less, I usually cut off the bottom, so 1 less than the standard side. So this is viewed as a negative. So here I have X and 2, and then I have X minus 1. So this is X plus 2 and X minus 1. And then to get another representation of that, we could foil this basically, but this actually carries all the way over to here, right? So we have to think about the things that we're adding and subtracting together. So this basically simplifies to the X squared plus X, because this negative cancels with one of these, leaving us just with 1X. And then we have these 2 negative tiles right here as minus 2. And we could have gotten that same thing just by going first, outer, inner, and last 2. Okay, we'll do just one more, and then I think it's kind of a longer task, but I think you'll be able to work your way through it just fine. One side is 2 less than the standard size, and the other side is 3 more than the standard size. So again, I put the more off the right, and then the less I'll do in a different color. It goes all the way across and all the way across. So here we have X plus 3, and here we have X minus 2. So it'll be X minus 2. times x plus 3. And again, we could FOIL if we wanted to, or we can combine our tiles together to see what we have, which is x squared minus, well, it might be plus actually. Let's count up our x's here. So we have these two negative ones, and then 3 positive ones, so that's a total of 1, and then we're going to have minus 6, and that comes from right here, the negative 6. So just work your way through this today. There is kind of a fancy way. Let's take this example here. Take x squared plus x minus 6. There's a way to take that and quickly turn it into, and we did it a little bit in 2.6, and quickly turn it back into